Before it talks about the bigger interval. Now the one we have, it talks about a small interval, very small interval. So today is the first day of the class. So today next 60 minutes we're gonna go over things that we'll cover entire fall semester. First we'll start with algebra. We'll try to identify the strength of algebra. It allows us to find the slope. What is the slope? Slope gives us direction and the steepness. And what is the shortcoming of algebra? The shortcoming of algebra is it cannot solve 0 over 0 problem. How can we resolve this problem? We need to use a better tool to resolve this problem, and that is calculus. So we will just gonna touch on the main point of calculus that we will cover throughout the whole semester. Just as the derivative. So what is derivative? Derivative is just the slope. It's a fancy way of saying the slope of a curve. The slope of a line, we use n equal to y2 minus y1 x2 minus x1. For slope of a curve, we use something called the limit rule. There are also 4 different ways of deriving the slope of a curve. That's a power rule, product rule, quotient rule, and chain rule. So there are 5 different ways you can find the slope of a curve. Limit rule, power rule, product rule, quotient rule, and chain rule. So we're gonna talk about that, and then finally I'm gonna give you a fundamental example, a very real life example to help you understand why calculus is the most important and elegant branch of mathematics. So let's get started. So number 1, we say find equation a line given 2 points 1, 2 and 5, 10. That's very easy. So this is x1, this is y1, x2 and y2. So step 1 and is y2 minus y1, x2 minus x1. So y2 is 10 minus y1 is 2, x2 is 5 minus xy is 1. So 8 over 4 is 2. How can we find the equation of the line? So y is mx minus x1 plus y1. So y is m is 2 x minus x1, and x1 is 1 plus y1 is 2. So y is 2x minus 2 plus 2. 2 to cancel, y is 2x. How can we graph this? Very easy. So we gotta write y equal to mx plus b. So in this case, the b is y-intercept. So y-intercept is 0. That is 1. So this is y equal to 2x. Now, if I give you another 2 point to find the slope, let's see. Number 2, find equation of line given 2 points 5, 8 and 5, 8. Is there any way you can find the equation of this line? No. If you can, let me know. I'll give you a. But why you can't? I'll show you why you cannot take the find the slope of these 2 points. This is x1, this is y1, x2, y2. So if we write and is y2 minus y1, x2 minus x1, what we see? y2 is 8 and y1 is 8. x2 is 5 and x1 is 5. So 0 over 0. 0 over 0 is undefined. You cannot. Someone in the class, I remember, said this is 0, but this is not 0. 0 over 0 is undefined. Okay. Now, how can we resolve this problem? We can resolve this problem by calculus. Why in calculus it allows us to approach to 0. We don't have to be at 0. As long as we approach to 0, how close, if this is 0, how close we can go to 0? As close as I want. I can go to very close to 0, very close to 0. Okay, so let's see how that works. Okay, so in algebra, I have I have y equal to x. I have another line which is y equal to x squared, which is the parabola, the positive part of the parabola. So let's graph it a little bit better. Okay. Right. So let's say in algebra I have a point. This is x1. That in calculus I have it x. This is x2. I have this one is. This is not x2. This is x plus h. X plus h, as I explained in the class, x plus h is a little bigger than x. How? What is the little bigger than x? Little bigger than x means if x is 1, little bigger than 1 is not 1.1. Is not even 1.000001. Is 1.0000000000000 and then 1 is very close to 1. That's what means x plus h. So x plus h. Now, if this is x1, what is this one? This is y1. And what is this guy? This is y2. So, slope is y2 minus y1 x2 minus x1. Very simple. We did it before. We did it one more time because we try to understand that. We can use that to understand the limit rule. Okay, now then what is this one? This one f of x, and this one f of x plus h. Alright, now let's use to derive the limit rule. How can we do that? F prime of x limit equal to limit h goes to 0. Okay. For just to help you understand it, I'll just write it. y2 minus y1 x2 minus x2. y2 will be replaced by this one because this is y2. So f of x plus h, and y1 should be replaced by this guy, f of x. Okay, now x2, this guy is x2, so x2 is x plus h, and instead of x we call it x plus h, and x1 is x, so you're just going to write x, so you can write f prime of x is equal to limit, and h goes to 0, f x is cancelled, and x plus h minus f of x over h. Ladies and gentlemen, this is the most beautiful, this is the most important, this is the most elegant equation in the entire math and science. Here it goes. In 1667, a 23-year-old student of Cambridge University sitting under a tree in his hometown, all of a sudden he saw an apple fall from above. With the fall of an apple, he revolutionized the entire picture of the universe. He started asking a series of questions. If the apple falls, what else? What else happened? Why the apple had to fall? Why it didn't go up? Instead of falling, why the apple didn't go up? So he started a series of questions, and at some point he looked at the sky and he saw a moon, and he asked a key question: if the apple falls, does the moon also fall? He wanted to solve this falling moon problem, but he couldn't because the math of his time was not advanced enough to help him solve the falling moon problem. So he spent lots of time thinking about it, and at some point he invented a new branch of mathematics now known as calculus. And the calculus allowed him to solve the falling moon problem. It also now allows us to solve many problems in physics, computer science, economics, you name it, even in medicine. There is a real application of calculus in medical field. You cannot limit the power of calculus. This is the most elegant branch of mathematics, and this is the most elegant formula. F prime of x equal to limit as h equals to 0 f of x plus h minus f of x over h. This is the most beautiful piece of equation in the history of the universe. Thanks God Newton looked at the moon. Thanks God Newton saw apple fall. Thanks God he asked a key question: if apple fall, does the moon also fall? Because that led him to invent calculus. Now, we already talked about that. How can you find the slope of a line? The slope of a line is very easy and equal to y2 minus y1 over x2 minus x1. But how can you find the slope of a crazy line like that? Slope of a crazy line like that, in order to find it, you have to use this formula. There are other ways to find the slope of curve, and we also gonna go over that. So let's use let's list them. How many ways we can take the derivative slope of the curve? There are 5 many ways. Derivative of curve. Okay. There are 5 different ways we can take the derivative. Number 1 is limit rule. We already show you the limit rule. F prime of x limit is equals to 0 f of x plus h minus f of x over h. Then the power rule. Okay. The power rule is, I'm going to give you an example right here. So the power rule is pretty simple. Is x, if you have y equal to x exponent, then you write y prime equal to n x n minus 1. I'll give you an example in a second. Right here. Product rule. Okay. If you have y equal to a plus b and c plus d, you can call this one first and you can call this one second. Then you can write y prime equal to derivative of first and second plus derivative of second and first. And then, of course, limit rule, power rule, product rule, quotient rule. Quotient rule. Derivative of term times bottom minus derivative of bottom times term over bottom is clear. And then finally we're going to do a chain rule. Chain rule is as follows. Let's do chain rule on this side. triangle. So you have y is x plus y. There is an exponent. So your y prime is, let's call this one log. So n, we are looking log n minus 1 f prime of log. Okay, so now let's give you an example. So example, let's say y equal to x squared. And this example is y equal to x squared. Why not? And this y equal to x plus 1, x minus 1. And this y equal to x4 over x squared. And then this one, example, can be y equal to x plus 1 squared. So let's do this one using the limit rule. We already established the fact that the limit rule is f prime of x equal to limit as h goes to 0 f of x plus h minus f of x over h. You need to memorize that. I have no problem if you forget your name, but I have a problem if you forget the limit rule. There would be a problem between you and me if you forget the limit rule. This is something I want you to memorize, I want you to understand, and I want you to use to solve every single calculus problem. So, you're going to write this down. F prime of x, limit as h goes to 0, f of x plus h minus f of x over h. Okay. Now f prime of x as limit h goes to 0, so x plus h squared minus x squared over h. F prime of x is equal to limit as h goes to 0, x squared plus 2xh plus h squared minus x squared over h. F prime of x as a limit h goes to 0, this x squared cancel 2xh plus h squared over h. So f prime of x is limit as h goes to 0. So we factor out h, so 2x plus h over h. H is cancelled. F prime of x equal to limit as h goes to 0, 2x plus h. Now h goes to 0 means h goes to 0. F prime of x is equal to this final answer. So we're gonna solve same problem using the power rule. Let's see how that goes. As we explained that the rule of the power rule is this one. So y prime is n x n minus 1. So we know that n is 2 and x is x. So y prime is 2x 2 minus 1. So y prime is 2x 1. So y prime is 2x. Let's solve the other problem. So y prime is, we know that derivative of first times second plus derivative of second times first. So y prime is derivative of first. So what is the derivative of x? Derivative of x is 1. So 1, when derivative of x is 1, let's see, y is x. What is the exponent? Exponent is 1. So let's write y is n x n minus 1. That's the power rule. We're going to use the power rule. So power rule sitting inside the product rule, power rule sitting inside the quotient rule, power rule sitting inside the chain rule, power rule sitting inside every single rules of derivative. So you need to know power rule very well. So y is n is 1, x n minus 1, 1 minus 1. So y is x, 1 minus 1 is 0. So y is x, 0 is 1. So the derivative of x is 1 and derivative of 1 is 0. Derivative of 2 is 0. Derivative of any constant is 0. What about derivative of 2 million? That's a big number. But still the derivative of any constant. 2 million, 10 million, 2 billion, 10 billion, 10 trillion, 0. So 1 plus 0. plus. What is the derivative? Okay, first, 1 second, x minus 1. Derivative of second, 1 minus 0, and first. So y prime is 1 x minus 1 plus 1 x plus 1. X minus 1 plus x plus 1. So this is cancelled, so y prime is just 2x. So let's solve this one. We already said that derivative of top. So y prime is derivative of top. Derivative of top is 4x 4 minus 1. And then the bottom, that is here. And then we're going to write minus derivative of bottom, that is 2x 2 minus 1. And then top, that's 4. Our bottom is here, which is x4, because x squared 4 is squared, so that is x4. So y prime is 4x 3 x squared minus 2x 1 x4 over x4. So y prime is 4x 3 plus 2 5 minus 2x 1 plus 4, which is 5 over x4. So y prime is 2x5 over x4. So y prime is 2x5 minus 4. So then y prime is just 2x. Now the last one is the chain rule. And this is our rule. And chain rule, as we said, that y prime is supposed to be n block n minus 1 n prime of block. Okay, this is my formula. If you look in the book, you're not going to see this formula. This is my formula. I try to make it easy so that you understand, and once you understand it, you can use any complicated formula. So y prime is n is 2, block is x plus 1. So block is x plus 1. 2 minus 1, f prime of x plus 1. So y1 is 2x plus 1. This is just 1, and f prime, we already talked about it. Derivative of x is 1 and derivative of 1 is 0. So y prime is 2x plus 1 and then 1. So y prime is 2x plus 1. Alright, so this is the final. Okay, now you saw that we show you how to find the slope of a curve. How to find the slope of a curve using a very sophisticated tool, and that is the derivative. There are 5 ways to find the derivative: limit rule, power rule, product rule, quotient rule, and then finally chain rule. Now I will give you an example to help you understand what does really it means when h goes to 0. Example: Professor Bari went out to a bike trip, went out to a 1.5 hour long bike trip, and his position function is 40 over 3. Okay, so P of t equal to 40 over 3 t squared. What I want you to find, in 20 miles, is speed What I'm interested is that did he break the law? Did break the law? Okay. So let's see. Step 1. Graph the scenario. So Professor Bari started his bike trip. So when he started his bike trip, the distance must be 0. So d initial must be 0. And the time also must be 0. So t initial also must be 0. At the end, the time is given 1.5 hour. 1.5 hour means 1.5 hour. One and a half is 3/2. So t final is 3/2 hour, and d final we don't know, but we'll find out. Very easy to find out since we have the position function. So let's find it out. Step 1 would be, step 2 would be finding d final. So can we find d final? As long as we know the time, and if we put the time inside the position function, that gives us the final distance. So P of t is equal to 40/3 t squared. So P of 3/2 is 40/3. This is 3/2 squared, and then P of 3/2 is 40/3, 9/4. 4 goes to 40, just 10. 3 goes to 9, just 3. So P of 3/2 is just 30 miles. So he traveled 30 miles. He started at 0 miles. He traveled 30 miles. It took him 1.5 hours or 1.5 hours. 30 miles. Now we can do something. Now we can find the average speed. However, we did not finish the graph. We know that in 20 miles of his bike trip, he saw a speed limit sign which is 25 miles per hour. Which is 25 miles per hour. He saw a speed limit sign 25 miles per hour. So speed limit sign. So his speed limit sign 25 miles per hour. And at 20 miles of this journey. So this D, whatever you call it, D2 is 20 miles. And he saw 25 miles per hour. Well, we want to know whether he break the law right here. We don't care about whether he break the law right here, or we don't care how fast he was moving over there. We don't care how fast he was. We only care how fast he was moving over there, because the cop want to know whether he was moving faster than 25 miles per hour. If he does, the cop will give him a ticket. Let's see. Then step 2, graph it. We know that this is some kind of a parabola, because t squared. The degree 2 tells us it is a parabola. So let's draw a parabola. Okay. Now we know that the time it took is 1.5. So this is 0.5. This is 1, and this is 1.5. This is t, and this is d. And the distance was 30 miles. So this is 10 miles, 20 miles, 30 miles. Okay, so we have 2 points. One is 0, 0. One is 0, 0, and other is 1.5, 30. So 0, 0 is right here, and the other is right here. So we're going to draw a line. And the slope of this line is going to tell us his average speed. Now let's find the slope of this line. Slope of this, the red line. And we know that the slope formula is y2 minus y1 x2 minus x1, but it is tradition that the time we put over here t2 minus t1 and d2 minus d1. Okay, so t2 is 1.5, this is 3 over 2, minus t1 is 0, d2 is, we know that 30 minus 0, so 30 times 2 over 3, 3 goes to 30 times, it's 20 miles per hour. So the slope of this red line is 20 miles per hour. 20 miles per hour. Does that mean he did not break the law? No, it does not tell us anything, because we don't care about what he was doing here. We don't care about what he was doing here. We even don't care about what he was doing here. Not even here. We just care about what he was doing right here, right at that point. Not before, not after. This is too big of an interval. This does not tell the cop anything. So we have to make the interval as small as we possibly can. How can we do that? We don't know calculus. Without calculus, how can we do that? Well, let's see. Let's find, we know that D2. But let's find the T2 over here. How can we find the T2? It's very easy. We use the position function again, which can be step 3. So, for T over 3, T squared is T of T. So we want to know the time at 20 miles. So 20 miles. Time at 20 miles. So that's what we put. 40 over 3 t squared. Now what you're going to do, you're going to cross multiply. So you're going to write 40 t squared is equal to 60. So t squared is 60 over 40, 0 cancel, 2 and 3. So t squared is 3 over 2. So t is the square root of t is equal to 1.22. So we're going to write T2 is 1.22. Now we're gonna create a list. We're gonna keep track how algebra can help us and when algebra become helpless. At some point we'll see that the algebra will become really helpless. And if we observe that, we will in fact celebrate that because then we're going to see real beauty of calculus, and we're going to see that. Okay, so this is algebra, and this is calculus. So algebra, the first slope it gives us when the interval is from beginning to end, big slope, Hub doesn't care about that. That is 20 miles per hour. So 20 miles per hour. Let's see the next one. Step 4. Step 4 we're going to write and is y2 minus y1 x2 minus x1. Now instead of y we're going to write d2, d1, t2 and t1. So in this case we have very smaller. We're going to create a smaller interval. We're not going to use that interval. We're going to be clever. If this is 1.22, where is 1? 1 must be right here, very close to 1.22. So we're going to write, here is the T1. Here is the T1. Forget about this thing now. Care about this thing. 1 hour. 1.22 hour. If the 1.22 hour is here, 1 hour must be there. So you call it 1 hour. So once you know where is 1 hour is right before 1.22, then you can find D1. How can you find D1? Once you know T, you can find D using the position function. So let's write step 4. Step 4, PT is T over 3 T squared. So P in this case is 1 hour. This is 40 over 3. 1 squared. So 40 over 3 is divided by 3 is 13.33. So P of at 1 hour is 13.33. So the D1 is, this is mine. So D1 is 13.33 mile. Okay, now we can find the slope again. Now we have 1.22 minus 1, and on the top we have 20 miles minus, this is 20 minus 13.33. So on the top we have 6.67, and on the bottom we have 1.22 minus 1 is 0.22, so 30.31. So the next approximation is 30.31 miles per hour, and that's better than the one we have before. The one we have before is talks about the bigger interval. Now the one we have, it talks about a small interval, very small interval. The small interval is better because the person is, we care about what was Professor Bari was doing right here, right at that moment, and that small interval tells us a better picture about what he was doing right at that time, right between 1.1 to 1.22 at that time, then the bigger interval. So now that's good. That tells us that what he was doing, but that's not enough because we do not know what he was doing exactly at that point. But how can we do that? One way we can do that, making h goes to 0, which is step 5. d2 minus d2 over t2 minus t2. So d2 is 20 miles. At 20 miles, 1.22 and 1.22. There is a problem, 0 over 0. The algebra doesn't allow h goes to 0. Algebra does not allow the h goes to 0. That's the most important thing we need to understand. Algebra does not allow h goes to 0. That's why we need to use calculus. How the calculus is going to help us? Let's see. No good, because it's undefined. Now here comes calculus. Calculus is going to tell us what happening exactly at that point. So step 6. So P of t is equal to 40 over 3 t square. Now long time ago we talked about the limit rule of derivative, which is f prime of x is equal to limit h goes to 0 f of x plus h minus f of x over h. We can write f of x limit h goes to 0. So now we are write, instead of x plus h, we're going to write t plus h. So t plus h is square minus so we're going to write, we have to be careful, 40 over 3 t plus h is square minus 40 over 3 t square over h. So f prime of x is limit as h goes to 0, 40 over 3 t square plus 2th plus h square minus 40 over 3 t square. This has to be in the parentheses. Okay, now let's see, we're going to just figure that f prime of x is equal to limit as h goes to 0, 40 over 3 t square plus 80 over 3 th plus 40 over 3 h square minus 40 over 3 t square, everything over h. So 40 over 3 t square, 40 over 3 will cancel, so that's good. So now we can write f prime of x is limit as h goes to 0, 80 over 3 th plus 40 over 3 h square over h. Okay, so now f prime of x is equal to limit h equals to 0. So there is the h, there is a you're gonna factor of h. So h, you're gonna factor out. You're gonna factor of h. Okay, so you're gonna factor of h. So h 80 over 3t plus 40 over 3h over h. So h is cancelled. So f prime of x is limit h equals to 0, 80 over 3t plus 40 over 3h. Now we said that limit h equals to 0, so that h equals to 0. So that f prime of, we have to know what was happening at when t was 1.22 hour. T is 1.22 hour. We plug that in. So 1.22 is, we no longer have to write limit. So we already left that h equals to 0. So 80 over 3, 1.22. So 2 is equal to 32.5 miles per hour. So the calculus gives us 32.5 miles per hour at 1.22 hours. At right here, at right here, not right there, not right there, not right there, not right there. At exactly 1.22, it tells us what he was doing, and this Professor Bari was moving really fast at exactly 1.22. So he in fact broke the law. So did he break the law? Yeah, he broke the law. We just used the calculus and found that out that he was moving 32.5 miles per hour, exactly 1.22.